Last time we tackled sine x over x. Now here's a cousin of that problem. What is 1 minus cosine x, divided by x, as x approaches 0? This time the answer isn't 1. It's 0. Let's see why. We already proved that sine x over x approaches 1 as x approaches 0. Watch it happen again on this small graph. As x slides in towards 0, the curve's height slides right up to 1. Keep that result in your back pocket, we're about to lean on it. Plot g of x equals 1 minus cosine x, over x, and again there's a hole right at 0, since plugging in x equals 0 gives 0 over 0. Does that hole sit at 0? At 1? Somewhere else entirely? Let's find out. Go back to the unit circle. For a small angle theta, cosine theta is the horizontal coordinate of our point. That's the blue leg running along the axis. The remaining sliver out to the circle's rightmost edge, in red, is exactly 1 minus cosine theta, the gap we care about. Notice the right angle where those two legs meet, and notice they add up to the full radius. Cosine theta, plus the gap, equals 1. That same right triangle gives us something more useful. By the Pythagorean identity, sine squared theta equals 1 minus cosine squared theta, and that factors as 1 minus cosine theta, times 1 plus cosine theta. Hang on to that. It's exactly the move we'll make in the algebra in a moment. Now watch two numbers update live as theta shrinks. The gap over theta keeps sliding towards 0, but the gap over theta squared settles down near 1/2, not 0. That's the tell. The gap isn't just shrinking, it's shrinking quadratically, like theta squared, which is much faster than theta itself shrinks. Let's zoom in and actually watch that race happen. Same zoom level, same magnification, for both sides, the blue leg and the red gap. As theta keeps shrinking, watch the red gap collapse almost instantly to nothing, while the blue leg is still clearly sitting there. The gap over theta squared holds near 1/2 the whole time, confirming, in a single picture, that 1 minus cosine theta vanishes like theta squared, not like theta. Here's how to prove it symbolically. Start with 1 minus cosine x, over x. Multiply top and bottom by 1 plus cosine x, that's the conjugate trick. On top, 1 minus cosine x, times 1 plus cosine x, is 1 minus cosine squared x, and that's exactly the identity we just watched on the circle, so it becomes sine squared x. So the whole expression becomes sine squared x, divided by x times 1 plus cosine x. Split that into two separate factors, sine x over x, times sine x over 1 plus cosine x. We already know the first factor heads to 1, that's the green result from last time. The second factor, as x goes to 0, sine x goes to 0, while 1 plus cosine x goes to 2. So that whole fraction heads to 0 over 2, which is 0. A number heading to 1, multiplied by a number heading to 0, gives a product heading to 0. Watch the dot slide in from the right, its value ticking down towards 0, then watch it slide in from the left too, its value ticking up towards 0 from below. Both directions land in the same place. So the limit of 1 minus cosine x, over x, as x approaches 0, is exactly 0, the perfect partner to the result we proved last time.